So in this question, you're given three relations. You're asked to find which of these relations are functions and which are not functions. So let us try to analyze one by one. So if you take the first relation, so this relation is defined between two sets R1. What is the domain of this relation? 2, 5, 8, 11, 14. That's the set of all first elements. 2, 5, 8, 11, 14. And what is the codomain, or what is the range of this relation? 1, 1, 1, 1, 1. You have only one element here. And what are the connections that you have? 2 is connected to 1, 5 is connected to 1, 8 is connected to 1, 11 is connected to 1, 14 is connected to 1. So is this relation a function? Yes, because what are the conditions that needs to be satisfied? Every element in set 1 should have an image, and every element in set 1 should have only one image. So every element has only one image in the second set. Hence, this is a function. There's no doubt about it. Next, let us go for the second relation. So, what is the domain of this relation? 2, 4, 6, 8, 10, right? 2, 4, 6, 8, 10. So, what is the range of this relation? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now 2 is related to 1, 4 is related to 2, 6 is related to 3, 8 is related to 4, 10 is related to 5. So is this a function? Again, yes, because every element in the first set is connected with a unique element in the second set. Hence, this is also a function. Now let's go for the third one. So in the third relation, R3. So what is the domain? 1, 1 and 2. So you have two elements in the first set, and in the second set you have 3, 5, 5. That is 3 and 5. So what are the connections that you have? 1 is connected to 3, 1 is connected to 5, 2 is also connected to 5. So this is not a function because every element in the first set is connected to some element in the second set, but one has more than one image. So one has first image, second image. So every element should have only one image. Here one has two images. Hence, this is not a function. So the first two are functions, third is not a function. So in this question, you're given two functions, f of x and g of x. F of x is x square if x is in between 0 and 3, including 0 and 3, and 3x if 3 less than or equal to x less than or equal to 10. And g of x is again the same functions but between different limits, 0 to 2 and 2 to 10. So you're asked to show that f of x is a function but g of x is not a function. So let me try to show this using graph method. So we know that x square is a nice function and 3x is also a nice function. So if you draw the graph of this first function, so let this be 0 and let this be 3 and let this be 10. So I'm not drawing the graph to the scale, I'm just drawing a schematic graph. So between 0 to 3, the function is x square. You know the graph of y is equal to x square. So the graph looks like this, right? And at x is equal to 3, the graph goes to 9. And what is happening from this 3 to 10? So from 3 to 10, f of x is equal to 3x. So 3 is included here as well as here. So if x is equal to 3, from this side also you're getting 3 into 3 is 9. So that is, the graph is just starting from this point. But now this is a straight line, 3x. It is, at x is equal to 10, you go till 30. So you have graph something like this. This is a straight line. So as you can very clearly see, this curve is satisfying the vertical line test. It is between 0 to 10. So between 0 to 10, wherever you draw a vertical line, the line is cutting the graph at only one point. Hence, this f of x is a function. There is no doubt about it. Next, let us try to draw the graph of g of x. So between 0 to 3 and 3 to 10. Now so this graph is divided at x is equal to 2. So between 0 and 2, y is equal to x square. That is, you have a parabolic curve. So at x is equal to 2, you are reaching 4 here. X square is reaching 4. But at x is equal to 2, it is also defined as 3x. That is, at x is equal to 2, it also has a value of 6. So it is also starting from 6, and we have a straight line graph, 3x is reaching 30. So this curve also seems to satisfy the vertical line test. That is, at any point if you draw the vertical line, it is cutting the graph at only one point, but there is a special point which is x is equal to 2. If you draw a vertical line at x is equal to 2, you are getting the functional value which is equal to 4 as well as a functional value which is equal to 6. That is, the number 2 is related to 4 as well as 6. A single element has more than one image, hence this is not a function. So even if one element has more than one image, this will not be a function. So if this have to be made into a function, if you just remove this equal to here or here, at one of these points, if you remove the inequality, then this will be a function. So in this question, you are given that you have a relation which connects the elements of the form AB to the elements of the form A plus B, where A and B are both natural numbers. So the question is to check whether R is a function or not. So the question is R a function? If you have to prove that this is a function, you have to check that for every element you have a unique image. So what I can very clearly see is that this is not a function. So I'll try to give a counter example. So now, this relation connects elements of set of natural numbers to set of natural numbers, because if A and B are natural numbers, obviously A into B will also be a natural number, and A plus B will also be a natural number, right? So now let us take an example. What are the sample elements that this relation connects? So now let us take A is equal to 2 and B is equal to 3. So let us take A is equal to 2 and B is equal to 3. So correspond to A is equal to and B is equal to 3. What are the elements that this relation is mapping? So A into B is 6 and A plus B is 5. 6 is being mapped to 5. So let us take another example. A is equal to 1 and B is equal to 6. So correspond to A is equal to 1 and B is equal to 6. What are the mappings that this relation is doing? AB 1 into 6 is 6 and A plus B is 7. That means the 6 is being related to 7 also. The 6 is related to 7 also. As you can very clearly see, one element is being mapped to more than one element. Hence, this is not a function. And this is not a function. So you can create many more counter examples, but one counter example is sufficient to disprove that this is a function. Thank you.